Example problem 3 reads, light is incident on a water surface at an angle of 30 degrees to the normal. What is the angle of the light to the normal in the water? The refractive index of air is 1.0 and the refractive index of water is 1.33. This is a Snell's law problem, and the equation for Snell's law is N1 sine of angle 1 equals N2 sine of angle 2. So you're going to have a set of n's, an N1 and an N2, and you're going to have a set of angles, an angle 1 and an angle 2. Now you have to determine which set is going to be the 1's and which set is going to be the 2's. So in this problem, you have, we're going to draw a picture at the top. You have some water, and then you have some light in air. So the light is coming in at an angle, striking the water, and then continuing on into the water. So the problem reads that light is incident on a water surface at an angle of 30 degrees to the normal. So this is the surface of the water. When the light strikes the water, it's creating an angle here. So that 30 degrees is actually going to belong to the air, not the water. So angle 1 is going to be 30 degrees. The problem then goes on to ask you, what is the angle of the light to the normal in the water? So they want to know the angle here. So we're going to be looking for angle 2. It says the refractive index, which we already know to be N, of air is 1.00. And then the refractive index of water is 1.33. So now that we know all of our variables, we can plug everything into the equation. So we have 1 times the sine of 30 degrees equals 1.33 times the sine of some unknown angle. At this point, you need to go into your calculator and you need to put the calculator in degree mode, not in radian mode. This problem will not work if you're in units of radians. You have to be in units of degrees in this problem. So now that you've got your calculator in degrees, which for me, you just click mode and then you go down to the third row and then you just hit degree and then you press clear and you go back to the beginning. So sine of 30 degrees, so sine of 30 is going to equal 5 times 10 to the minus 1. And the way that I wrote that in my calculator, I just pressed the sine button and open parentheses came up automatically. I typed 30 and then I pressed enter. And so that's what that equals. So at this point, you have 5 times 10 to the minus 1 equals 1.33 sine of angle 2. We've got to get rid of this 1.33. So we're going to divide by 1.33. And we're going to do that to the other side as well. So divided by 1.33, you're going to get 3.759 times 10 to the minus 1 equals sine of angle 2. So at this point, we have to figure out how to calculate angle 2 from this problem. And the way we're going to do that is by taking the inverse sign. And an inverse sign is just sine minus 1. It's usually on top of the sine button on a Texas Instrument 84. You have to click second and then the sine minus 1 button comes up. And that's what we're going to do to both sides. So we're going to take the inverse sine of 3.759 times 10 to the minus 1, inverse sine of angle 2, and the inverse sine of angle 2 is the angle. So in our calculators, second sine minus 1, 3.759 second e to the minus 1, close parentheses, that is going to equal about 22 degrees, and that is going to be your angle 2. So that is how you work this problem, and let me know if you have any questions about example problem 3.